Hi, I'm Mr. Daddy. Welcome to Science Teacher Channel. Behold the tuning fork. Is it the correct one? Do you think this is the tuning fork? No, it's wrong. Behold the tuning fork. Hi everyone.
When an object vibrates, it pushes the surrounding air molecules into one another, starting a chain reaction of collisions through the air. These collisions travel in waves. When they strike your eardrum, it vibrates. This vibration is converted into electrical signals that your brain recognizes as sound.
The cochlea is filled with salt water-like fluid. So when the sound wave reach our ear, it will make the eardrum or tympanic membrane to vibrate. And the tiny bone of the middle ear thus convert the large movement of eardrum into pressure wave in the fluid of the cochlea. When sound enter the ear canal, it hit the eardrum and make it vibrate like the head of the drum vibrating. The eardrum jerk a bone called hammer, which hit the anvil and moved to the third bone called the stapes. Its motion pushed the fluid within the long chamber of cochlea. Once the sound vibration have finally converted into vibration of fluid, they travel like a wave from one end of the cochlea to another. A surface called the basilar membrane runs the length of the cochlea. It is lined with hair cells that have specialized components called stereocilia, which move with the vibration of the cochlear fluid and the basilar membrane. The signal travels through the hair cell into the auditory nerve. Not every hair cell move, only selected one, depending on the frequency of the sound. This comes down to some fine engineering. At one end, the basilar membrane is stiff, vibrating only in response to short wavelength, high frequency sound. The other is more flexible, vibrating only in the presence of long wavelength, low frequency sound. So the noise that is made by seagull or mosquito vibrate different location on the basilar membrane, like playing different keys on a piano. But that's not all that's going on. The brain still has another important task to fulfill: identifying where a sound is coming from and compare the sound coming into the two ears to locate the source in space.
The big idea today is that when matter vibrate, it needs something to travel through, and that something is air. We cannot see it, but we are going to do our best to show science in action. I need something to move. I need a ruler. Hold one end of the ruler on the table. When you twang the ruler, it will start to vibrate. You can see it vibrate and you can hear the sound. Or you can use plastic ruler to see the difference. And you can also use shorter ruler. Can you see the difference? Or you can have rubber band with a container. We have 3 different types of rubber band. Can you see the difference? cut. You can use a box or food container like this. Watch what happens when we plug the rubber band. Nah, you can arrange the rubber band on the box or on the food container. Watch what happens when we plug the rubber band. Or we can tighten the rubber band. I can see the rubber band vibrating. I can hear the sound. The sound travels from the rubber band through the air into my ears. My eardrum moving when the sound wave hit it. My hands are moving and my hand vibrating. My very effective mom just served us noodle. I can feel my vocal cord vibrating. The sound wave comes out and travels through the air. Science is so cool. I wish I can see the sound and sound wave, but we cannot. We can only see the effect and hear the sound. I have straws. I will pick one straw and I will cut the end, make it flat, and cut triangle shape. Now we can blow it to make it vibrate and create sound. We can change the sound by changing the length. It's fun, right? You can try it at home. Science is cool. I wish we can see the sound and the sound wave, but we cannot. We can only see the effect and hear the sound. In chapter 12, we build our knowledge about making and describing sound and how sound travel and how sound can be changed. In chapter 12, we build our knowledge about making and describing sound, how the sound travel, how sound can be changed. Before we continue with this topic, it is helpful if you understand that sound produced by vibrating object and how musical instrument sound can be changed. Sound are caused by vibration. Sometimes we can see the vibration, but mostly we can feel the vibration. Sound can be described by a range of vocabulary: high, low, loud, quiet, vibration, pitch, and volume. It's also useful if you have experience of vibrating source, such as musical instrument. Musical instrument can be blow, hit, or pluck. This musical instrument can be grouped based on how we play it. This group of instruments are called percussion when you hit the music instrument, wind when you blow it, and you can pluck the string. Changing the nature of vibration will change the sound produced. Some of the way to change the vibration of musical instrument are blow harder, cover the hole, put a finger to make the string shorter, or changing the thickness of the string. Previously, we have some experiment that produce sound. So we can describe the sound, how the sound is produced. When we pluck the rubber band vibrating. When we twang the ruler moving up and down. When we making voice, our muscle vibrating. There is often a lot of confusion between words used to describe the volume, loud, quiet, and word used to describe pitch, high pitch and low pitch. Many students will have encountered the word pitch to describe the frequency of sound. Frequency is the speed of the vibration. Low frequency and high frequency. Frequency is measured by the number of wave cycles that occur in 1 second. The unit of frequency is hertz. Frequency determines the pitch of the sound. So the pitch of a sound depends on the frequency, while loudness of sound depends on the amplitude of sound wave, the length and the width of the wave. The wavelength is the distance between two peaks of the sound wave. To understand more about sound wave, you can explore online. You can choose the oscillation and then you can change the amplitude. You can see it is higher, or you can change the frequency. This is high frequency, high pitch sound, and this is low pitch sound. At the end of this video, you will have human sound frequency test and low pitch, high pitch sound. Remember, you have to control the volume.